My name is Teddy, and today I'm going to teach you about ionic bonding. If you know nothing about it, that is completely fine. Just sit back and let me enlighten you. If you've ever played with a magnet, you probably know that one side is labeled south and one is labeled north. Each direction corresponds to either a positive or a negative charge. When the positive side of the magnet comes near the negative side of another, they're drawn together, which is very similar to the way an ionic bond works. Ionic bonds are one type of chemical bond, the other two being metallic and covalent. Before the bond is formed, each atom has a neutral charge. First, one atom loses an electron, gaining a slight positive charge. We call this a cation. The other gains an electron to become negatively charged and is called an anion. Each ion is acting like one side of the magnet. Now that each side has an opposite charge, the two ions are pulled together by a force called electrostatic attraction, and an ionic bond is formed. This is very different from a covalent bond since the electrons are not being shared by the two atoms. The only thing that keeps the ionic bond together is the electrostatic attraction between them. When determining the ratio of atoms in an ionic compound, we first have to look at the charge on each atom. As an example, I'm going to use sodium and oxygen. Sodium loses one electron to gain a +1 charge, but oxygen gains 2 electrons and gets a -2 charge. When the bond is formed, it takes 2 sodium ions to neutralize the charge of the oxygen. The compound that is formed is Na2O. Another example is calcium chloride. Ca has a +2 charge, while Cl has a -1 charge, and the compound that is formed is CaCl2. The reason that we see these bonds form is due to the fact that atoms are most stable with a full valence shell. An atom like oxygen only needs 2 electrons to fill its valence shell, and sodium has 1 extra electron to give. 2 sodium atoms bond to the oxygen so that each shell is completely filled. Typically, we see ionic bonds between a metal and a nonmetal because the difference in electronegativities are so large. That means that one atom is able to pull away an electron from another atom instead of sharing it like what happens in covalent bonds. When compounds are formed from ionic bonding, they create a crystalline pattern called a crystal lattice. Each positive ion is surrounded by negative ions and vice versa. Table salt is an ionic compound and a very good example of the crystalline lattice structure formed by ionic bonding. So most ionic compounds are soluble in water since it is polar. This means that one side of the molecule has a slight positive charge while the other has a slight negative charge, and the polarity of the water molecule is able to separate the compound into its ions. These ions are free to move without being constricted, which is why an ionic compound dissolved in water can easily conduct electricity compared to a non-dissolved ionic compound. There are many properties that are common and almost universal to ionic compounds. Most are very hard and brittle due to their crystal lattice shape. While they are good conductors in an aqueous solution, they are very good insulators in the solid form. They also have high melting and boiling points since it takes a very large amount of energy to break the crystal lattice structure. So thanks again for watching. I'm Teddy, and that was ionic bonding.